This question says that solve the differential equation 1 plus x squared dy minus 2xy dx equals to 0. Find the partial solutions satisfying the initial condition y of 0 equal to 1. So we have been given our differential equation. So we are going to use a similar method as our previous, as question A. So our differential equation is 1 plus x squared dy minus 2xy dx to be equal to 0, and our initial condition is y of 0 equal to 1. So here we know that this condition is simply x equal to 0 and y equal to 1. Good. So we need to solve this differential equation. By the way, this is called ordinary differential equation. So to solve this, we are going to use the method of separating variables. So there are so many methods in which you can use in solving an ordinary differential equation, but the easiest is always separating the variables. Once you're able to separate the variables, you can immediately get the solution. So we're going to do the same thing here. So the first thing, we need to separate our variables. So we have to send this entire term to the right hand side. So this will be 1 plus x squared dy to be equals to 2xy dx. So what I want to do here is to separate the variables, which means on the left hand side there should be our function all in terms of either x or y, depending on how you want it, and on the right hand side you should have your variable either in terms of x or y, but generally on the left hand side is always our function in terms of y, and on the right hand side is always our function in terms of x. So in order to do that, we want any function or any term in terms of x to be on the right hand side. So the first thing we need to do is to divide all through by 1 plus x squared. Divide all through by 1 plus x squared. So this is going to cancel. We'll be left with dy equals to 2xy dx divided by 1 plus x squared. So we notice that on the left hand side our function is in terms of y, but on the right hand side our function is in terms of x and y. We don't want that. So the first thing we need to do is to divide all through by y on the right hand side. So if I divide all through by y, we notice that this y is going to cancel, and we'll be left with dy on y to be equals to 2x all over 1 plus x squared dx. So we take our integral on both sides. Once we take our integral on both sides, we solve our differential equation. So on the left hand side, we notice we already saw this earlier. This is simply the ln of the absolute value of y to be equal to the integral of 2x all over 1 plus x squared dx. So the solution, this is simply the integral of this, right, is simply the ln of absolute value of 1 plus x squared. So again, there are so many methods in which you can solve this. If you notice, right, we can use substitution, integration by substitution. If we let like u to be equal to 1 plus x squared, then du should be equal to 2x dx. You notice that 2x dx is what is on our numerator here. So this numerator, we are going to represent it as du. So this will simply mean that we have the integral of du all over. We know that 1 plus x squared is our u, right? So we already saw again that this is a ln of u, and this will simply be the ln of u was 1 plus x squared, and since ln is a positive function, we put our absolute value. So that's how I got the solution from here to here. To be safe, it's always important to like solve it manually, use your substitution, and at the end have this result. So that's the solution for the right hand side. So we're going to proceed. We know that we have okay, let me just create some space here. So we have the ln of absolute value of y to be equal to the ln of absolute value of 1 plus x squared. Since there were no upper or lower bounds, this will be plus a constant k. So the first thing we need to do is use the conditions that were given to us above, that is y of 0 equals to 1, to get the value of the constant k and substitute it in our solved differential equation, and look for the value of y. So as we saw, x is 0, y is 1. So this will simply be the ln of 1 to be equals to the ln of 1 plus k. The ln of 1 is 0, and the ln of k is 0, so k, and the ln of 1 is 0. The ln of 1 is 0, so simply k will be 0. So substituting this back here, we are going to have a ln of y to be equal to the ln of 1 plus x squared plus 0, which is still, that same function. And now we take our exponent, like the inverse and natural logarithm, which is exponent, and we already saw this property, and so this will be our absolute value of y to be equal to the absolute value of 1 plus x squared. So that's our solution.